Okay, welcome back. Today we're going to do Unit 4, Lesson 3, Antiderivatives and Indefinite Integration. What is this? Well, indefinite integration is just an extension of definite integration. So we have some definitions and vocabulary here. A function f of x, capital F of x, is an antiderivative of a function f of x if capital F prime of x is equal to f of x for all x in the domain of f. The process of finding an antiderivative is antidifferentiation. Antidifferentiation is basically the exact same thing as integration. And a family of antiderivatives is the indefinite integral of f with respect to x, and it's denoted by the integral f of x dx. And this is the most important one. If f is a function such that f prime of x is equal to f of x, then the integral of f of x dx is equal to capital F of x plus c. That's called the general solution, and c is the constant of integration. This is the important thing. Do not forget to add plus c, 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 plus c. That's so important. If you do not write plus c, I will mark points off. BC Calc will knock points off. AP College Board will knock points off. It's not going to happen. So, we're given a derivative. We want to find the antiderivative. Here we're given f of x is equal to 8. So we're going to actually find the derivative of 8 with respect to x. This is going to be equal to 8x plus c. You absolutely have to have the plus c there in order for this to be correct. That plus c means plus a constant. It's so important. Here we have g of x equals 3x. Well, that's going to be the integral of 3x dx, which is equal to, excuse me, 3 halves x squared plus c. Right? F of t is equal to t squared. Hopefully you can see this okay. That's the integral of t squared dt is equal to 1/3 t cubed plus c. The integral of cosine of theta, d theta. Well, what has a derivative of cosine? That's going to be sine. So this is going to be equal to sine theta plus c. Hopefully you're kind of getting the picture here. Square root of t is the same as t to the 1/2. So we have the integral of t to the 1/2. dt is going to be equal to t to the 1/2 would be 3/2. So it'll be 2/3 t to the 3/2 plus c. 1 over t is t to the negative 1. The integral of t to the negative 1 dt is equal to negative 1 over plus 1. What? Oh my gosh, what am I doing? Why would I do all of this? That's ridiculous. Ignore all of that. This is just equal to the natural log of t plus c. Goodness, that's ridiculous. This is also absolute value, but that's not that important at the moment. Okay, I really kind of got away from it there. This is equal to t to the negative 2. So we have the integral of t to the negative 2 dt, which is going to be plus 1 is, so we're going to have negative 1 over t plus c. The integral of sine theta d theta is equal to negative cosine theta plus c. V of t, well, this is going to be the integral of 12 minus 32t dt, which equals 12t minus 16t squared plus c. Good. And e to the x is just the integral of e to the x dx, which is just equal to e to the x plus c. So hopefully all of that makes sense. Now, we have some basic integration rules that I'm going to show you. I didn't write all of these out because honestly it's going to take an eternity, but here are our basic integration rules, and I have a document of this saved in the file, but basically the derivative of c is 0, the integral of 0 is c, okay? Derivative of k of x is k, integral of k is kx plus c. K, I think you can kind of just read through these and see summation and addition and subtraction, right? These are going to break up. X to the n minus 1. X to the n is x to the n plus 1 over n plus 1 plus c. That's kind of a fun one. Trig, kind of go backwards with these. You got to have these memorized, don't forget. And some transcendental functions, e to the x a to the x natural log of x. Well, a to the x is a to the x over natural log of a. That's a good one to remember. And then the one that tripped me up because I overthought it, 1 over x is just natural log of x plus c. Good? All right, so let's do a few more examples here and move on. So we are given the integral of 5e to the t plus 1 over cosine squared t dt. Now, there's a lot going on here, and some of the best ways to integrate is to actually break this up and make it simpler for yourself. So I'm going to rewrite this as the integral of 5e to the t, and I could have even taken that 5 outside if I wanted, and I'm not going to today, plus, well, 1 over cosine squared t dt is the same as secant squared t dt. Well, now I know my integral of 5e to the t is just going to be 5e to the t. And my integral of secant squared, we already know that, we have that memorized, is tangent t. And this is all plus c. You do not need to have plus c in both spots. You can just have 1 plus c, and that takes care of it. That's plenty, all right? Here we have the integral of 3x minus 1 quantity squared dx. This I would rewrite as the integral, and I would actually multiply this out, right? So I would have 9x squared minus 6x plus 1 dx. And then I can actually just take my integral here, so I'm going to have 3x cubed minus 3x squared plus x plus c, all right? And finally, another example here. We have x squared plus 4x plus 5 over x to the 5th dx, the integral of that. Well, this can be rewritten as the integral of, and you can obviously divide each portion here. So this is going to be the integral of x to the negative 3 plus 4x to the negative 4 plus 5x to the negative 5 dx. And that's going to be equal to, we're going to have a negative 1/2 x to the negative 2 minus 4/3, right? Minus, yes, x to the negative 3 minus again 5/4 x to the negative 4 plus c. And if I want, I can rewrite that to be nice and neat. Oops, not add, subtract. Minus 5 over 4x to the 4th plus c. All right? Nice and easy. So that's how you evaluate an indefinite integral. But we can actually solve differential equations that are subject to given conditions. Sometimes you actually have to solve for c. So here we are given f prime of x is equal to x squared plus x minus 7. And f of 3 is equal to 1. And we actually want to find what that is. So we're going to take the integral of x squared plus x minus 7 dx. So that's going to be equal to 1/3 x. Actually, I'm going to rewrite this here. So f of x, and I probably should have had an f of x here. F of x. So f of x is equal to 1/3 x cubed plus 1/2 x squared minus 7x. Now I'm going to say that f of 3 is equal to 1/3 times, and I'm going to use this information, right? So we're going to have 3 cubed plus 1/2 times 3 squared minus 7 times 3, and all of that's equal to 1. Because actually this, I've made a mistake here, and what is that mistake that I made? I forgot to put this plus c right here. That is absolutely essential. You have to have that plus c. That's what we're trying to find now. So this is going to be 1/3 times 27 plus 1/2 times 9 minus 21 equals 1, oops, plus c equals 1. Oh gosh, I'm a mess today. Equals 1. We're solving for c. I need to have that c there. Why didn't I erase that? I'll erase all of this so that you can kind of see it better. Plus c equals 1. We have to find what c is. So 27 thirds, anyway, just trust me that c is equal to 8.5. So what's our final function? Well, f of x is equal to 1/3 x cubed plus 1/2 x squared minus 7x plus 8.5. We actually found the exact solution there. Okay? Let's do another one. Let's see if I can be a little bit neater with this one. We have f prime of theta equals sine theta, and f of 0 is equal to 2. Well, we want to find the integral, so we're going to take the integral of both sides. Now, when you're doing this, you can actually think of it as you're actually just taking the integral of both sides of this, all right? So that is what we're doing. So f of theta is going to be equal to negative cosine theta plus c, all right? Now f of 0 is going to be equal to the negative cosine of 0 plus c, and all of that's going to equal to 2. Well, negative cosine of 0 is just going to be, cosine of 0 is 1, so we're going to have negative 1 plus c is equal to 2. So c is equal to 3. So our whole function, f of theta, is equal to negative cosine of theta plus 3. All right? So hopefully, I don't know why this kept becoming fuzzy, but hopefully all of that makes sense. I'll see you in class. Like and subscribe, and I'll see you later. If you have comments, leave them below. All right, see you later. Bye.